Ground control to Major Tom. Take your protein pills and put your helmet on. 10. Ground control 9, to Major Tom. 8, 7, 6. Commencing countdown, engines on. 3, 2. Check ignition, 1. And may God's love be with you.
Hey guys, welcome back to my channel. I want to talk to you guys today a little bit about the anatomy of a black hole. So this is going to in no way be the same as the really cool video that I sent you, so check that out. I know the documentary is a little long, that's why I extended the due date, but I just wanted to run through some terms with you guys really quickly. So here we have a rudimentary drawing of a black hole, and specifically this black hole would be one that is actively feeding on interstellar material, other stars, neutron stars, white dwarfs, even black holes. Supermassive black holes in general are not picky eaters. They'll consume any matter or light that comes near them. So let's take a look at what an actively feeding black hole looks like. What are the parts? So the primary thing you notice straight away, the thing that gives a black hole its name, is something called the event horizon. This would appear as a black sphere in space, a spherical region where not even light can escape. If we remember back to our gravity unit, we talked about escape velocity a little bit. So to escape the Earth's gravity, we talked about Newton's cannon. You fire the cannonball harder and harder until eventually you're orbiting the Earth. So to escape the gravity well of a massive object, you need to attain a certain velocity. Well, at the event horizon, the escape velocity from the collapsed star inside is equal to the speed of light. So at any distance inside that event horizon, the escape velocity exceeds the speed of light. So that means not even light itself can escape, thus the term black hole. Now, when we say the collapsed star, what do we mean? Well, buried inside the event horizon is something called the singularity. Really, the singularity is physics speak for we have no idea what this is because the laws of physics don't really work anymore here. In essence, if you remember from the neutron star video, matter is squeezed so tightly together that the electrons and protons can't repel anymore. They're jammed inside, and you get a sea of neutrons that butt up against each other. Now, the Pauli exclusion principle is enough to hold up the neutron star against gravity's might. You have something called neutron degeneracy pressure, so the neutrons don't want to be forced any closer together. And we talk about no two bits of matter may ever occupy the same space at the same time in our universe. Well, inside a black hole, we don't really know what's going on. In this case, gravity's force is so out of control that even the neutron degenerate pressure is overcome. And the Pauli exclusion principle may not be enough to keep particles apart anymore, and the star collapses into a single point, into an infinitely dense point. We don't know for sure, but what we do know is the gravity is intense. And if you recall, it's not just about the mass, it's the fact that this thing is so tiny.
Muffins! The black hole is looking a lot bigger. Does anybody want to admit to throwing things in?
No.
Me. We even still have that thing?
And I have to ask, has anyone seen the cat?
Now what?
Okay, it's possible someone may have started a business called Magic Crap Hole Waste Removal, but it wasn't me.
Ew. Stop! This is a black hole, not a lawn and leaf bag. If one more thing gets in there, it could reach critical mass.
did it! I hit my first home run!
I'm still proud of you, buddy. And look, I got money to take you for pizza. Yeah, you saw that I had the money, right?
Remember our gravity unit, all that mess, big G, M1, M2 over R squared. So it's the distance. All that matter is packed into a tiny, tiny area. The singularity can't be revealed to us, but we know that it's hidden somewhere inside, and we know that because the object must have mass, because we can see that it has gravity. A few of the other features that you see on an actively feeding black hole, one is something called the accretion disk. This is a lot like a protoplanetary disk. So when we have a protostar collapsing down and rotating, all that gas and dust gets spread out and flattened out into a disk, which forms our planets. Well, in this case, matter is being torn apart down to the subatomic level and orbiting the black hole rapidly. These collisions are causing a soup of charged particles, and anytime you have a bunch of charged particles whirling around really fast, you generate a magnetic field. So this black hole would also have an intense magnetic field surrounding it, and from that magnetic field is where we get these two features here. These are called relativistic jets. So the black hole itself isn't emitting anything. Anything that crosses this horizon never escapes again. But around the black hole, you can have a magnetic field so strong that it can eject particles at extremely high velocities. When we're talking about fractions of light speed, physicists use the term relativistic, referring to Einstein's famous relativity equations. So these things are traveling at substantial fractions of the speed of light, a third, a half the speed of light. And that's why we can see these immense beams of X-rays and charged particles and ions being emitted from actively feeding black holes. Another cool feature is in this area surrounding the black hole is something called the photon sphere. I have it drawn here on the edge, but it would actually cover the entire thing. If you looked at an actively feeding black hole, it might not look like you expect. It would probably be pretty bright. And the photon sphere is the minimum orbit that a photon of light can achieve and not be sucked into the black hole. So this is light itself orbiting the black hole, trapped in orbit around it. These things are bonkers. And let me know if you liked that longer documentary. There's a bunch of really cool longer documentaries out there, and if you enjoyed that over the short clips, I can assign those and give you lots more time so you can break it up. And I purchased a surprise for you guys for our next video. We'll be moving the classroom outside, so hopefully I can do some better drawings. And don't worry, I have some cool art projects and stuff in the works for you guys too. So enjoy the rest of your afternoon, and I'll see you back here next time.